Hello everybody, hopefully you guys are having a good day and being really good for Mr. Fredericks. He's a great guy, so be nice to him. I'm probably sitting on some warm sunny beach, sorry, hate to rub it in, but you know, still having a good time. Anyhow, so Mr. Fredericks probably has passed out this activity 7.3. If he hasn't, go ahead and pause the film and pass out activity 7.3, and I'll wait. So go ahead and pause if you need to. Okay, hopefully you're back, and to do activity 7.3, number one, example 1, I'm going to graph this sequence. So hopefully you have graph paper. If not, I guess you just watch along or put it on your paper there. But if I want to graph the sequence, first of all, what I need to do is make it. So to make the sequence, remember, n is always what we call the counting numbers or the natural numbers. So n is always these numbers, 1, 2, 3, 4, you know, dot, dot, dot. It keeps going and going and going forever. So if I want to make the first term a1, let's plug in 1. We'll go, okay, 2 times 1 plus 1. So a1 is going to be 3. a2, 2 times 2 plus 1, because I'm just plugging in 2 in for n. That's going to be 5. a3 is going to be 2 times 3 plus 1, and that's going to be 6 plus 1 is 7. a4, plug in 4, 2 times 4 plus 1 is 8 plus 1, which is 9. Okay, I think I've got it basically the general idea of what I'm going to do here. Okay, so I'm going to go ahead and when I graph this, I'm going to make sure that my x-axis is n and my y-axis is going to be the value. Okay, so there's a1, so my first term, a1, plug in 2n, n is 3, n is 4, n is 5, and so forth and so on, okay? 1, 2, 3, 4, 5, 6, 7, 8, well, I won't quite get all the way up there, but this is a1, let's see, 1, 2, 3, 4, 5, 6, 7, 8. So, the first term has a value of 3. There you go. Second term has a value of 5. Third term has a value of 7. Fourth term is off my page, which is 9. I'll squeeze it up there. Okay, so what I notice, do not connect the dots. I'll say it again. Do not connect the dots. Do not connect the dots. Because there is no 3.5. There is no 4. There is no 5.6. It's just 3, 5, 7, 9. These are my terms. Now, this does appear to be straight, so it is definitely arithmetic. I know it's arithmetic because we're going up by 2's each time, all right? It's also straight, it's linear, okay? All right, let's take a look at example 1 and compare it to example 2. So I'm going to go ahead and create example 2. I'm going to put in a1. It's going to be a 3 times a 2 to the 1 minus 1. Let's see, 1 minus 1 is 0. I can use a calculator. I think a 0 power is going to be 1, so a1 is 3. a2, I'm going to plug 2 in for n. 3 times 2 to the 2 minus 1, 2 minus 1 power, which is going to be 6, because I get 2 to the 1 power times 3. a3, sorry, my bad. a3 is 3 times 2 to the 3 minus 1 power, which is 3 squared, which is 4 times 3, which is 12. a4 is 3 times 2 to the 4 minus 1 power. Let's see, 2 to the 3rd power is 8 times 3 is 24. And a 5, let's see, 3 times 2 to the 5 minus 1 power. Let's see, that's 4 to the 4th power, which is 16, times 3 is 48. Okay, if I look at these numbers, stand back, I'll look at these numbers. What I notice is that it seems like I'm doubling each time. And that makes sense because the base is 2. So I'm doubling, okay? If I graph this, okay, get my paper out to graph it. I'm going to go ahead again on my x-axis. I'm going to have to make this a little bit bigger. My x-axis is really called the n-axis. So n is 1, 2, 3, 4, 5. And you guys can ask Mr. Fredericks to pause this anytime it gets going too fast. I'm not here to see how your pacing's going, okay? I want to go all the way up to 48, so let's see, I'll probably go 10, 20, 30, 40. Yeah, maybe I'll do that. I'll go by fives. 10, 20, 30, 40, 50. That's going to work for me. So I'm going by fives. If I want to graph my sequence, I'm going to have value 3 for 1. It's about there. 2 is 6. It's about there. 3 is 12. It's about there. 4 is 24. 24 is about there. And 5 is 48, which is about there. Do not connect the dots. Do not connect the dots because there is no like 1.5 term. There is no 4.5 term. There's no values in between. Do not connect the dots. Don't even put a dot here because there's no 0 term, okay? So anyway, if I look at that, it looks curved, it looks exponential. Well, we call that geometric. So this one's definitely a geometric sequence. Okay, it's geometric sequence because it's being multiplied. It's being multiplied by 2 or by any number over and over again to make that sequence. Okay, so if it's a geometric sequence, then we are going to multiply by the same number to make the sequence. Now the number is r. We call r our ratio. So the number is r and it's called the ratio. We call it the ratio because r isn't always a whole number. Sometimes it's a fraction. Sometimes you can multiply by a half. Sometimes you can multiply by, I don't know, how about a 1/10, or maybe you multiply by 3/5 or whatever it may be. But we call it the ratio, okay? So it's the multiplier. R is the multiplier, okay? And here's our formula, okay? Our formula is a of n, which can make any term, a1, which is our first term, r, which is the multiplier, to the n minus 1 power. Now, if I check that out, okay, let me highlight this because that's our formula. If I check that out, oh, there it is. If I check that out, then if I look way up here to what I just did, I would know that 3 to have my first term. Turns out it is. 2 is my multiplier, my r, to the n minus 1 power. It is geometric, okay? All right, let's do example 3. Let's use our formula. So find the 14th term of 5, 15, 45, 135. Seems to me, if I look at this thing, seems to me as if it's being multiplied by 3 each time. So r is 3. If it's multiplied by 3 each time, it is definitely geometric. So if it's geometric, then I can use my formula, right? So if I want to make the 14th term, I would say, okay, I want a of 14. I want the 14th term, so n is 14. I want the 14th term, so I put 14 right there. So how do I do this? A of 14 is equal to, let's see, a1. Well, the first term is 5 times, I gotta grab a calculator, times r, and r is 3, to the n minus 1 power. Now in this case, since I want to find 14, 14 is the n. So to the 14 minus 1 power, okay? So I'm going to make this easy. Just change that to 13 for your calculator. So I'm really going to go a14 is equal to 5 times 3 to the 13th power, because 14 minus 1. I'm just going to use my calculator, okay? It's going to get big because I keep multiplying, so let's see how big it really gets. Okay, 5 times 3 to the power of 13. Pretty big number. Let's see, looks like 7 million. So if I keep going, I would get 7,971,615 would be my 14th term, okay? How am I doing? And again, if I get going too fast, ask Mr. Fredericks to pause it, and you can catch up, okay? All right, turn the page. All right, now, geometric series. There's a difference between series and sequences. So if you talk about series, then what we're doing is we're going to add them all up. It's the sum, which means to add all terms, okay? We're going to add all terms. So if we're going to add all terms, we need a formula. So here's our formula. S of n. S means sum. S of n means sum, and I'm going to highlight that because it's our formula for adding them all up. Okay. So we're going to go ahead and do S of n, which is the sum of however many terms. A1 is our first term, 1 minus r to the n power, that's whatever term we want, all divided by parentheses. You have to have the parentheses, 1 minus your multiplier, okay? R is your multiplier. So let's look at example 4. Find the sum of the first 14 terms of 5, 15, 45, 135, dot, dot, dot. Well, this is the one we just did. So we do know the first term, A1, is 5. We know the multiplier, R, is 3, because you multiply by 3, multiply by 3, multiply by 3 until you get it, okay? So if we were to flip the page back for just a second, and instead of making all these terms, add them all up, it's going to be bigger than this. It's going to be much bigger than this because that's our last term. We've got to add all the terms prior to that. So let's go back and use our formula. So here's our problem, example 4. Let's use our formula. So we want S of 14 because we're looking for the sum of the first 14 terms. We're just going to add them up, add them up, add them up. Now you could, if you wanted to, just keep adding on your calculator. It'll work. But what a pain. Formula is so much better. So A1 is 5. Parentheses, 1 minus R is 3. To the n power, well, we want the first 14, so n is 14. So 3 to the 14th power. All divided by parentheses 1 minus r, which is 3. Okay, you absolutely have to have the parentheses for your calculator. Have to have them in the right place, otherwise it will not work. Okay, definitely do put your parentheses here in your calculator and here. All right, so let's see what happens if I do this. Okay, so I'm going to go, all right, I'm going to go 5 parentheses 1 minus 3 to the power of 14. Move my arrow over. Parentheses divided by parentheses 1 minus 3 parentheses. Okay, you have to have the parentheses in there. Enter. And it should be a big number because you're adding these all up. Let's see. Boom. Looks like 11 million. So the sum would be 11,957,420. Okay? So that's if you went 5 plus 15, you got an answer. Plus 45, you get an answer. Plus 135, you get an answer. Plus the next one, plus the next one, plus the next one, plus, until you've added all 14 terms, and you get 11,957,000. Okay, so right now, Mr. Fredericks, if you want to pause the film, I want the kids to grab their journals, okay? Grab your journals and go to page 207. Okay, go ahead and pause it on page 207. All right, hopefully you're back. Page 207 in our journals. Okay, so let's take a look at some vocabulary. Geometric sequence. So we're going to multiply, right? Multiply to make the next term. Okay. Common ratio, that's the multiplier. That's R. That's our multiplier. Multiply, whatever, multiplier. And then the geometric series is just to add them all up. Add up all terms. But of course we're talking about adding up a geometric ones, okay? So geometric sequence is multiply to make the next term. So we're going to times by 2, times by 2, or times by 5, times by 5, times by 1/2, whatever it may be. The multiplier is the common ratio. The geometric series is where you're going to add up all terms, okay? So we have a formula. Here's our formula for the sequence. A of n equals A1, r to the n minus 1. Okay? But then if you multiply them, it's a series. Okay? It's a series. And we have a new formula. A1 times 1 minus r to the n all over 1 minus r. Okay? That's our formula for the geometric series. And we already have that in our worksheet. So let's turn the page, okay? Take a look at page 208, okay? Page 208. So first of all, it says, tell whether it's geometric. Okay, explain your reasoning. So what I would do is this. Okay, I have a suspicion that probably it's times by 3, right? So I'm going to go, okay, what's 4 times 3? 12 times 3, 36. Yeah, it's working times 3. 108, yeah, times 3. Hey, it's got to be geometric. It's got to be geometric because I can multiply by 3. So my reasoning is r equals 3, or in words, we're multiplying by 3 each time to make it, okay? Okay, let's look at 2. Let's look at number 2. So number 2, I'm going to go, okay, it doesn't look like I'm multiplying at all. It looks like I'm subtracting 5, which makes it arithmetic. It's not geometric at all. Okay. All right, let's shift on down. Number 5, let's write a rule. Okay, so it sure looks like it is multiply by 3, multiply by 3, multiply by 3, and I can check it on my calculator. But so I know that it's geometric. Okay, so we're going to think about it. We want to write a rule. If it's geometric, we need a formula. So we have a formula. There's a formula. Okay, I'm going to use that formula right there. So I'll write it down. Our formula is a of n equals a1 r to the n minus 1 power. That's my formula, okay? Since I'm going to write a formula, I need a variable. So we're going to keep n as a variable. Keep n as a variable. We have to make a formula. And formulas have to have variables so you can plug things in, okay? So I'm going to keep n as a variable, so I'm going to rewrite this as a formula. I'm going to go a of n equals a1. Well, I know what a1 is. a1 is 6. So I'll put 6 right here. The multiplier r is 3. I know r is 3 because I'm multiplying by 3, so r is 3. So we go 3. And again, I'm trying to make a formula, so we keep n as a variable. N minus 1. Now, do not multiply 6 and 3. Do not do this. Do not multiply 6 times 3. Can't do that. You have to be able to do your exponents before you can multiply. Since you cannot do exponents, you have to stop there. That is our formula. It will create this sequence, okay? All right, let's look at number 6. Okay, so it appears it goes positive, negative, positive, negative. So I think what we're doing is multiplying by a negative number. I believe we're multiplying by a negative 2 each time. Let's see. 3 times negative 2 is negative 6. A negative times a negative 6 times negative 2 is a positive 12. 12 times negative 2 is negative 24. So it is geometric. R is negative 2, a1 is 3, so let's use our formula. A of n equals a1 r to the n minus 1 power. So a of n, let's do this, okay? A of n equals, remember we're going to keep n as a variable, equals a1, which is 3. My multiplier, r, is negative 2 to the n minus 1 power. There's my formula. Keep n as a variable. Do not multiply those. Do not multiply those. That's 3 times negative 2. You cannot do that because you have to do the exponents first. Okay, so shift over real quick. Let's move it over to number 10, okay? We're going to do 10, and then we're going to do 12, okay? And then I'll be done. Okay, number 10. Write a rule for the nth term of the geometric series. Okay, so first of all, I know a3, I know a6. I need a1, okay? It tells me it's geometric, so I need to figure out what r is and a1. So first of all, let's figure out what r is. So if I trick this problem, let's say that, let's just trick it, and for just a minute, let's say a1 is 54. So if I move this one back from 3 to 1, I'll move a6, we'll go from 6, 5, 4. So all I'm doing is shifting myself in the formula. I've gone from the third term, and I'm moving it back to the first term, and I'll move this one back to the fourth term. That's all I'm doing, okay? I'm moving both back to my a1 term. Okay, so from here I can use my formula. I know my formula is a of n equals a1 r to the n minus 1 power, okay? So then, what I want to find is r more than anything. So a of 4. So what I'm going to do is let n equal 4. In this case, n is equal to 4. So I'm going to put my 1,458 here. and when I say that's my fourth term, is equal to A1, which I now have changed to 54. And I don't know R, but I'm going to find out what R is. R to the n minus 1 power, okay? So then to the 4 minus 1 power, because this is my fourth term. My 1,458 is my fourth term. To get my fourth term, I need to let n equal 4. Okay, so let's simplify it. First step is divide by 54. Divide by 54. Let me do that real quickly. So I'm going to go 1,000, my calculator, 1,458. I'm going to divide that by 54, and I get an answer of 27. So I get 27 equals R. Let's see, that's R cubed, isn't it? R cubed. If I cube root R, cube root, right? I'm a cube root. Solve for R, cube root. R's got to be 3, okay? So R equals 3. Okay, now, what do we need a formula? Okay, so what I'd like to do is find A1, okay? So one way to find A1 is just back up 54, okay? I do know A3. Now think about this. I know if I were to go A1, A2, A3, so forth. So I know that the third term really is 54, okay? Now, let's be smart about this. 54 is my third term. A1, A2, A3. So, to back up, I know I had to multiply to get this one. Multiply by 3 to get this one. I had to multiply this one by 3 to get to this one. I had to multiply by 3 to get this one. So let's just do the opposite. Divide by 3 will give me this one. Divide by 3 will give this one. Okay, so 54 divided by 3. 54 divided by 3, I think we just said was 27. Hold on, 54 divided by 3 is 18. So just divide by 3. Divide that by 3, and I get 6. So my very first term, A1's got to be 6. All right, so let's make a formula. All right, my formula is, this is a rule, A of n equals A1 times R to the n minus 1 power, right? And then what I'm going to do is, I need to keep n as a variable. I'm making a rule, so keep n as a variable. So I'll go A of n equals A1, which we know is 6 now. R is 3. We found out R is 3 to the n minus 1 power. And that will create this geometric sequence. Okay? All right, let's go to 12. We're getting there. Okay? 12. Now, first of all, in 12, it's the sum. It is geometric. It fits the geometric sequence perfectly. Okay? What we need to do is find the sum. So we've got a formula, right? And we had our formula in our notes. Our formula is this: S of n, A1, 1 minus R to the n all over 1 minus R. So let me write that down. So the formula I want to use on this one is S of n, sorry about that, S, A1, I'm going to go S of n equals A1 times my 1 minus R to the n power all over 1 minus R. Okay, so I want to find the sum. First of all, let me create a few terms. Okay, so let's plug in 1. Actually, I'll plug in 0. So it starts at 0. So I'm going to plug in 0, 1, 2, 3, dot, dot, dot. Okay, so I plug in 0. Let's see. Plug in 0. Just use my calculator. I'll show you my calculator. Plug in 0. Plug in 0. So I'm going to go 3 times, let's make that 1.5, it might get easier, to the 0 minus 1 power, and let's see what we get. Okay, so I'm going to go, okay, 3 times 0.5 to the negative 1 power, right? And do that again, 3 times 0.5 to the negative 1 power, and I get 2. Okay, so my first term is 2. A1 is 2. Okay. And then the next thing I want to do is plug 2 in here. Okay, so I'm going to go S of, well, how many terms are there? You think there's 10, but there's not. There's 11. The n equals 11, not 10. You think 0 to 10? Oh, we got to count 0. So we count 0. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Plus, we have to count 0. So we have 11 terms. We're going to have 11 terms because of the 0. I'm not going to get tricked by that. So I'm going to go S of 11 because there are 11 terms. A1 is 2. 1 minus my multiplier, we know is 1.5 or 3 halves. I'm going to put my 1.5 to the 11th power divided by 1 minus my multiplier, which is my 1.5, parentheses. Now I'm going to be really careful with my calculator, making sure I use my parentheses in my spot. So here we go. Let's check this out on my calculator. Okay, so if I go, okay, I'm going to go 2 times 1 minus 1.5, oops, put the parentheses in the wrong spot, to the power of 11, parentheses, divided by parentheses, 1 minus 1.5, and I get an answer of 341.99, or about 342, if you want to round it up. All right, that's all I have for right now. You have homework. Mr. Fredericks passed that out. I need you guys to work quietly. He will put on a film with a little bit of time left in the class.